Before we start our rational functions unit, we need to do a review of factoring because almost every problem that we do with rational functions, we need to be able to factor. So, if you remember, the very first thing that we do in any kind of factoring is we want to start by taking a GCF out front of the entire problem, and we want to put the rest of the problem in parentheses. Not every problem is going to have a GCF, but we always want to start by seeing if there is one. And then after that, we want to see how many terms there are. If there are 2 terms left in your parentheses here, then you're either going to be factoring by difference of squares or difference of cubes or sum of cubes. We'll review those techniques a little bit later on. If there are 3 terms, then you're going to be factoring by the AC method. Now when there's 3 terms, the format is going to be ax squared plus bx plus c. In the AC method, we're going to take the first term ax squared times the last term c. So we'll have ax squared times c, and then we're going to look for pairs that would multiply to give me ax squared times c, whatever that is, but add to give me the middle term of bx. And then what we do once we find that pair is we split the middle term bx into those other 2 pairs that we had there. So we end up with ax squared plus some number times x plus some other number times x plus c. And then we're going to factor that by grouping. So we group these 2 terms together, group these 2 terms together. We take out a GCF from this first group, which will leave us with some GCF out front times a parenthesis after we take that out. And then we have to make this other parenthesis match the first parenthesis. So then we figure out what GCF has to come out from this second group, and we put that here. And then we're going to group together the matches. So we'll have one parenthesis that has the matching parenthesis, and the other parenthesis will have GCF1 plus GCF2. Now that's just a generalized idea of how to do AC method. I'm going to show you some examples just to refresh your memory even more. Example 1, x cubed plus 4x squared minus 21x. So we want to start by seeing if there's a GCF for all the terms. And it looks like I can take an x out of each term. So we'll do x and then parenthesis. Divide x out of x cubed, leaves me x squared. Divide x out, leaves me 4x. Divide x, leaves me minus 21. Now this x has to stay out front the whole rest of the time. So I'm just going to put that there to remind me. And then I see that I have 3 terms, so I'm going to factor by the AC method. So I want to figure out what a times c is. So that's x squared times negative 21, so negative 21x squared. And then I need a pair that would multiply to give me negative 21x squared, but add to give me 4x. And it's positive 4x, so I have to watch my signs. In order to get negative 21x squared, one of my pairs is going to need to be positive, the other will be negative. So I kind of start by listing out what multiplies to give me 21x squared. X times 21x, 3x times 7x, and then I want to see which pair would combine to give me 4x, and it looks like 3 and 7. In order to get positive 4, my 7x needs to be positive and my 3x needs to be negative. So this is the group that's going to work, and I'm going to rewrite my problem over here replacing the 4x with minus 3x plus 7x. So I have x squared minus 3x plus 7x minus 21. And then I'm going to group these together, group those together. Remember, I got to leave that x all the way out front. So what can come out of this first group is just an x. And when I take that x out, I'm left with x minus 3. In my second group, I have to match x minus 3. So what I would need to take out in order to match x minus 3 is positive 7. So I keep going, keep that x out to the front, and then I'm going to have a parenthesis that has my match, so x minus 3, times a parenthesis that has my GCFs in it, so x plus 7. And now that's factored. Let's look at another example. 4x squared plus 8x plus 3. So we want to see, do we have a GCF for all three of those terms? Nothing will divide all of them, so the only GCF would be 1, which we don't need to worry about. So we move on. I have 3 terms, so I'm doing AC method. So I take my first term, 4x squared, times my third term, 3. So I got 12x squared. And I need pairs that will multiply to 12x squared, but add to give me positive 8x. So my possibilities are x and 12x, or 2x and 6x, or 3x and 4x. Since it's positive 12x squared and positive 8x, I know both of my factors are going to be positive, and the one that will add up to give me 8x is 2x times 6x. So I rewrite my problem as 4x squared plus 2x plus 6x plus 3. And then I factor by grouping. In that first group, I can take out a 2x, so 2x, divide 4x squared by 2x leaves me 2x, divide 2x by 2x leaves me plus 1. And then I know in my second group I have to match 2x plus 1, so I think, what do I need to divide to get 2x plus 1 left behind? And that answer is positive 3, so I put plus 3. Then I'm going to make my 2 parentheses. Remember, 1 will be the matching parenthesis, so 2x plus 1, times the GCFs, which are 2x plus 3. And now that is factored. The next example is x squared plus 14x plus 49. Do we have a GCF? The only thing that can divide out of all 3 terms is a 1, so we don't need to worry about it. We have 3 terms, so AC method, we need x squared times 49, so 49x squared. I need pairs that multiply to 49x squared, but add to positive 14x. The more you factor, the faster you'll be able to figure out what that pair is. It looks like 7x and 7x. So we're going to split our 14x. So it makes x squared plus 7x plus 7x plus 49. And then group, just like we've been doing. The first group, we can take out an x, which leaves us x plus 7. In the second group, we have to match x plus 7, which means I need to divide out a 7. That's positive. So I make my 2 parentheses. The first one is the matching parenthesis. The second one is the GCFs, which is x plus 7 So I could write this as x plus 7 times x plus 7, or I could write it as x plus 7 squared. Okay, let's see what's next. 3x squared plus 6x minus 72. We always start by seeing if there is a GCF. It looks like everything's divisible by 3. So we'll put a 3 out front and then divide each term by 3, which leaves me x squared plus 2x minus 36. I have 3 terms left in my parentheses, so I'm doing AC method again. So I'm going to do x squared times negative 36 is negative 36x squared. And I'm going to need a pair of factors that multiplies to give me negative 36x squared, but adds to give me positive 2x. So I kind of start listing through my factor pairs. Oh, I skipped 4x and 9x. Oh, hey, guess what? 72 divided by 3 is 24. Just kidding. So let's redo that. Negative 24x squared. So x and 24x, 2x, 12x, 3x, and 8x, 4x, and 6x. Okay, that's better. So I need a pair that multiplies to give me negative 24x squared, but adds to give me positive 2x. So in order to multiply to give me a negative number, one of these must be positive and one must be negative. So I'm looking for a pair that would, if the signs were opposite, add to give me 2x. So that's going to be the 4x and 6x. In order to get a positive 2x when I add them together, my 6x has to be the positive and my 4x has to be the negative. So I'm going to rewrite my problem. Remember, you got to keep that 3 all the way in the front. I do x squared, and then instead of plus 2x, I'm going to use this pair right here. Minus 4x plus 6x minus 24. And then we group these two together. We group these two together. So we have 3. I can take an x out of the first group, so x times x minus 4. Remember, your second parenthesis must match x minus 4. So I would need to divide out positive 6. Keep that 3 all the way out front. And then I still need the 3, and then my matching parenthesis would be x minus 4, and my GCFs would be x plus 6. Okay, next one. We'll do 2 more that are AC method, and then we'll move on to difference of squares. 3x squared plus 7x minus 20. Feel free to work ahead of me if you already get the hang of factoring, and then you can check your work. Let's see, GCF for these 3 terms is just 1, so we don't need to write that. 3 terms, so we've got AC method. 3x squared times negative 20, negative 60x squared. So I need a combination that multiplies to negative 60x squared, but adds to positive 7x. So I'll just start listing out the possibilities. I think that's all of them. In order to multiply to get negative 60x squared, one has to be positive, one has to be negative. Since this number is positive, my bigger number needs to be positive. So looking through here, If I did 2 and 30, that'd be 28. That'd be 17. That'd be a difference of 11. Here it is, difference of 7. In order to get positive 7x, I need positive 12, negative 5. So I'll rewrite this 3x squared plus 12x minus 5x minus 20. And then group. In my first group, I can take out a 3x, which will leave me with x plus 4. Remember that second group is going to have to match, so I have to have x plus 4 left in there. Well, what would I need to divide negative 5x by to be left with x, and divide negative 20 by to be left with positive 4? Well, the answer to that is negative 5, so I need a negative 5 out front. And then when I go to factor with my matching parenthesis, I have x plus 4, and then with my GCFs, I have 3x minus 5. This will be our last AC method, 8x squared minus 14x plus 3. Is there a GCF? Only one. So we AC method. So we're looking for a pair that would multiply to 24x squared, but add to negative 14x. Keep in mind you don't have to list all the possibilities if you can get them without making this entire list. So I need 2 that multiply to give me positive 24x, but add to give me negative 14x. Remember that a negative times a negative gives me a positive, and a negative plus a negative gives me a negative. So that's telling me that both of my factors have to have a negative sign. So the one that's going to work for me is 2x and 12x, but I'll have to make both of them negative. So I'll rewrite 8x squared minus 2x minus 12x plus 3, and then group. From my first group, I can take out a 2x, which will leave me with 4x, and then be careful when you have this situation, because I got to do negative 2x divided by 2x, which leaves me negative 1. And then my second parenthesis is going to have to match 4x minus 1. So negative 12x divided by what gives me positive 4x? Or I can think positive 3 divided by what gives me negative 1. The answer to that is negative 3, and you can check that by distributing. See if I distribute negative 3 times 4 gives me negative 12. Negative 3 times negative 1 gives me positive 3, to make sure you have the right number out there. And then factor by putting my common parenthesis 4x minus 1 times my GCFs 2x minus 3. Okay, let's move on to factoring with two terms. So I'm first going to give you the formulas for difference of cubes and sum of cubes. Now those are not used very often, so we're not really going to practice with them. We'll practice with difference of squares. So let's see, difference of cubes and sum of cubes. You may remember these from studying them before. I'll just put a note here that these are rarely used, but we still need to be aware of them. Difference of cubes is when we have something that is cubed minus something else that is cubed. Sum of cubes is when we have something that is cubed plus something else that is cubed. So in each of these cases, what we're going to want to do is uncube each of these terms. so that we figure out what f is and what L is. And then that's what we're going to use in our formula. Both formulas start with a binomial, and then they have times a trinomial. So we have 2 terms times 3 terms. And they both start with FL and FL. So whatever you uncubed those to get, you have a binomial with both of those in there, times a trinomial that's going to be F times F at the beginning, L times L at the end, and in the middle is going to be F times L. So those are your 3 terms, F times F at the beginning, L times L at the end, F times L in the middle. And then remember that we fill in the signs with SOAP, S-O-A-P. The S stands for the same sign as the problem, so this one is negative. O stands for the opposite sign of the problem, that one's positive, and AP is always plus. So in sum of cubes, same sign, plus, opposite sign, minus, and then always plus. The one that you'll use a lot is difference of squares. And if you can recognize the pattern for difference of squares quickly, it will save you so much time. So difference of squares is when we have a square thing subtract another square thing. And so what we're going to do for each term is we're going to like unsquare them or take the square root of each one to give us F and L, like we did with sum and difference of cubes, except for those were cubed. So we unsquare each term, and then they just go into 2 binomials. The first one is F plus L, and the second one is F minus L. Simple as that. So let's look at a first example. 3x cubed minus 48x. So we always start factoring the same way by looking for a GCF. So what's in common here between 3x cubed and negative 48x? Well, we can divide out a 3 and we can divide out an x. So we're going to put 3x out front. 3x cubed, divide out 3x, leaves me x squared. Negative 48x, divide out 3x, leaves me minus 16. Now I have 2 terms in my parenthesis, and they're both square. So I'm going to unsquare them. X squared, you ask yourself what times itself gives me x squared, and that's x. And what times itself gives me 16, and that's 4. So I'm using the difference of squares formula, F plus L, F minus L. Remember to keep your GCF out front, so I'm going to have 3x times x plus 4 times x minus 4. And we're already done factoring. Let's look at another one. 2x squared minus 16x. So again, we're going to start with GCF. Looks like I can take out a 2 and an x. So I'll have 2x times 2x squared divided by 2x leaves me x. 16x divided by 2x leaves me negative 8. And then we look at our parentheses. Now, although we have 2 terms, neither of these terms is squared or cubed. So we can't use either of our patterns, any of our patterns, difference of cubes, sum of cubes, or difference of squares. In fact, since x isn't squared at all, that means we cannot break it down any further. So this is already in factored form. So we would be done just by taking out the GCF. You'll see that happen a lot too. So don't get freaked out if you take out a GCF and then you can't factor anymore. This will be our last one. So again, we want to look for a GCF. Both of those terms can divide out x, so we'll have x times x squared minus 81. Those are both square terms, so we kind of ask ourselves, what times itself gives me x squared? That's x. What times itself gives me 81, which is 9. Remember to keep your GCF out front, so we'll have x times f plus L times f minus L. So x plus 9 times x minus 9.